Ladies and gentlemen, good evening, and thank you very much for joining us here. With an audience of this quality and size, the Royal Academy of Engineering would like to do something else before I introduce the Hinton Lecture, and that is to honour someone who embodies all the things that the Royal Academy of Engineering stands for. We celebrate engineering success so as to inspire, support and challenge people to become engineering leaders of tomorrow. And so I'm delighted this evening to be able to introduce to you the winner of the Academy's Sustained Achievement Award, which we used to call the Lifetime Achievement Award. This award is usually made to an engineer resident in the United Kingdom whose achievements have had a profound impact upon the engineering discipline, but who has not been recognised earlier in their career, either because of the latency in the impact of their work or because of late disclosure due to national or commercial secrecy. The winner of the 2007 Sustained Achievement Award is William Johnson, who's with us here tonight, a Fellow of this Academy and a Fellow of the other society, the Royal Society. Professor Johnson has had a distinguished teaching and research career in a range of higher educational establishments. He's been a lecturer in mechanical engineering at the University of Sheffield, a senior lecturer in engineering at the University of Manchester, a professor of mechanical engineering at UMIST, a professor of mechanics at Cambridge University, and a United Technologies Distinguished Professor of Engineering at Purdue University in the United States. He's played a major contribution in the education of successive generations of engineers. He's written 10 books, founded the quarterly Journal of Impact Engineering, and produced hundreds of papers. His textbooks have been reprinted several times and translated into numerous languages. Professor Johnson has spent his working life in academia, but he hasn't lived in an ivory tower. He's known around the world in industrial circles for his breadth of knowledge in engineering and for his personal groundbreaking research, particularly in the fields of plasticity and solid mechanics. He's consistently applied his knowledge to the practical problems of industry, including extruding turbine blades, the breaking of the cutting edges of bolt cutters, and the study of V-anvil forging. He's also applied his skills to the defence sector, including areas such as projectile penetration and crash-resistant and blast-resistant structures. Professor William Johnson's sustained and multifaceted contribution to engineering makes him a worthy winner of the Royal Academy of Engineering Sustained Achievement Award, and I'd now like to invite Professor Johnson to join me on the stage to receive his medal, and I'm going to do it over there. Now, ladies and gentlemen, it's my very great pleasure to introduce the Royal Academy of Engineering's 2007 Hinton Lecture. The Hinton Lecture is this Academy's premier annual lecture. It's named after the late Lord Hinton of Bankside, the first president of the Fellowship of Engineering, which later became the Academy as we know it today. Lord Hinton was the first chairman of the Central Electricity Board. The speaker for the Hinton Lecture is always someone who's a leader in engineering and who drives forward technological change. I'm delighted, therefore, to be able to introduce you to tonight's speaker, David Waboso, Director of Engineering at London Underground. David is responsible for assuring the safety and reliability of all engineering assets on the operating railway. He has enormous experience of rail engineering projects, having worked on light rail, metro and mainline railways in both the public and private sectors. David has been a project manager on the Dockland Light Railway, the Jubilee Line Extension, and the systems director for the Thameslink Project. At the Strategic Rail Authority, David developed the organisation's technical strategy and focused on improving performance and controlling costs on the railway. He's also been a non-executive director of the Rail Safety and Standards Board. David is a chartered engineer, a fellow of the Institution of Civil Engineers and Railway Signal Engineers, and a fellow of this academy. London is the world's financial centre, and its people and businesses contribute significantly to the UK's overall economic performance. In the 21st century, London will need a first-class transport system if it's to continue to thrive. Tonight, David's going to give us an overview of the engineering challenges on London's Underground, the backbone of the capital's transport system. He's also going to discuss rail's potential for improving transport and economies around the world and the role of engineering in making that possible. Before handing over to David, I would like to thank the Academy's events teams for organising this lecture and to thank our sponsors for making this lecture possible: BAE Systems, E.ON, Microsoft, National Grid, Rolls-Royce and my old company, BP. We're deeply grateful to all of you for supporting this prestigious lecture. So, David, the floor is yours.
What can I say? Good evening, everybody. Thank you, Lord Brown. Distinguished guests, ladies and gentlemen. It's a great honour to be here and to see so many of you turning out. It's quite daunting, actually. There's a lot of faces in there I recognise who know more about what I'm going to say than I'm going to say. So it's great. Thanks for coming. It's truly a great honour. And also, it's such an honour to have been asked to become a Fellow of the Royal Academy of Engineering. It's truly humbling, and I'm very proud to do so. I'd obviously like to start off with just a few thanks and acknowledgements. I'm going to tonight represent the work not just of London Underground, but of our entire supply chain and delivery partners, and I pay tribute to them tonight as well. Everything I say here represents what we as the wider group, we employ between us over 30,000 people in the tied supply chain, so it's a large undertaking. So I do represent their views here. My boss, Tim O'Toole, can't be here tonight, unfortunately, but he's also somebody I'd like to thank. He's been an enormous inspiration over the couple of years I worked for him. And finally, and I think this goes for everybody who works on the railways, I'd like to thank our families for putting up with the hours we have to work sometimes. So thank you very much. What I plan to cover this evening is I'm going to start off with kind of an overview of what's going on in the world, because it's not just in London that we're investing these huge amounts in rail. There's exciting stuff right across the world. Obviously, I'm going to narrow down on London. I'm going to talk through some of our heritage assets, because some of them are really quite interesting. I think for some of you who may be not that familiar with railways, it's useful to have that background and understanding, because it puts into context some of the upgrading we're having to do. And we have such a rich heritage on the underground railway engineering. I do want to share some of that with you. Then I'm going to get into the meat of it, which is talking to you about how we're going to upgrade our deep tube lines and the subsurface railway with some of the real state-of-the-art control systems we've got coming in, which I'm sure you'll find fascinating. I'm then going to run a little movie that lasts a couple of minutes on cooling the tube. It just says it so much better than I can in a limited time, but I think you'll find that fascinating. Finally, I'm going to talk about how we pull all this together across the network, because with so much going on, the planning of what we're doing is just such a huge undertaking. It's like an army on the move every day. There are thousands and thousands of people working on our network, and just the way we manage all that is, I think, something that is very interesting. So that's what I'm going to talk for about an hour. I have had a cold in the last couple of weeks, and my voice isn't the best, so please do excuse me if I have to cough or take a break. So, a view of rail across the world. It is true to say that rail is experiencing a worldwide renaissance, and I think it's due to three main reasons. We do in London Underground keep quite close to what's happening around the world. We are founder members of an organisation called the Community of Metros, COMET for short, and through that we tend to find out what's going on across the world, and it's a really interesting view. And there seem to be three major reasons, if I dare characterise them that way, that rail is going through this sort of renaissance. The first one, and it's true for both passenger railways and freight railways, we have the unique advantage of mass movement centre to centre, largely because of the heritage of railways, but we can take people and goods from city centres to city centres. And often when you run the true comparison, especially with the cheaper airlines, where you have to queue up for an hour and then you're an hour away at the other end, we do compete very, very favourably. And again, with ever busier lifestyles and much more demand for people's time, that is becoming a real asset for rail travel. And we're seeing that around the world. The second thing, and this is peculiar for metros, is we can move literally hundreds of thousands of people through cities underground in very short periods of time. No other mode of transport comes anywhere near that. That is a superb and unique advantage of the underground. As Lord Brown said, it is the lifeblood of London. We just move people to work and take them from work. And that is a unique advantage. There's just no other form of transport that can do that. The final thing, and it is linked to this mass movement, because we are a per capita business, i.e. everything we produce in terms of emissions, you have to divide by the numbers of people we move. We are an incredibly attractive form of transport when it comes to the environment, simply because we move so many people using electricity. So that is also a very unique advantage. Now, if you add all those together, and you add the fact that rail is often used as an indicator of economic strength or as a catalyst for economic growth, it is no surprise that around the world there are a lot of rail schemes going. Interestingly, there's also a mix of public and private sector involvement. So what you're seeing around the world is quite a complex mix of regulation, both safety and economic, with all kinds of different structures. But the increasing involvement of the private sector means there has to be a form of regulation, which is interesting. So what are we doing around the world? Just a snapshot. There are hundreds of rail schemes. I just thought I'd pick a couple from each continent. In California, along the west coast between Los Angeles and San Francisco, they're starting what they call the bullet train, a 220-mile-an-hour high-speed train. With increasing technology now, we can move trains much, much, much faster, and we really are competing with airlines in terms of movement of people and goods. New York has a very, very good subway system, but already they are experiencing the same problems we have, which is the capacity is extremely limited. And on the 2nd Avenue subway, they're putting a brand new system in. Interestingly, New York, they're using the state-of-the-art train control systems that we are to get more capacity out of their fixed infrastructure. This is a theme I will keep returning to. One of the big problems we've had is we've got this fixed infrastructure and you cannot build new tubes underground. It's very, very expensive and it takes years and years. So the trick is to squeeze as much as you possibly can out of that infrastructure. And you'll see when I talk about some of our train control systems how we're trying to do that. But New York are doing that. Sao Paulo has one of the most thriving metro systems around the world, and for them it's just fantastic talking to them when we're in Comet, because they just are so proud of their metro system. It literally is the lifeblood of that city, and again they're having a huge extension there. If we go to Africa, in Nigeria, the Chinese are investing in 2 new high-speed lines that connect the north and the south, and that is something that China is increasingly doing in Africa, essentially using money using goods and services to buy the oil and other commodities. But again, for Nigeria, that is a symptom of forward-looking. They've got an old railway that was built by the Victorian engineers, narrow gauge, and that's fallen into disrepair. In Johannesburg, there's the GOW train, which is an 80-kilometre mass transit system, which is being developed, hopefully in time for the World Cup next year. In Australia, and we learned so much from Australia and New Zealand. They've been doing this business about modernising railways for a bit longer than we have. And they really do understand the whole asset management business, the trade-off between maintenance and renewals, and we do learn a lot from what's going on in Australia. But in Sydney, they're extending the existing metro there by another 12 kilometres, Sydney-Chatswood. If you go to Dubai, there's a $4 billion metro system using similar train control systems to the one we're going to be putting on the Jubilee Northern lines. But again, for that area, that is a first, really state-of-the-art, brand spanking new metro light rail system. China, what can I say? There are 15 separate cities planning metro schemes, 15. And in total, they'll have an installed capacity of around 1,700 kilometres of metro system. And that's compared to ours, which is about 400 kilometres, 800 kilometres if you count the double track. And finally, we come to Europe. Europe has this vision of essentially shrinking the cities by constructing dedicated high-speed lines between all the cities, of which we are now famously a part because we've got the high-speed line that now connects us through the Channel Tunnel to Stratford and St Pancras. And that is shrinking Europe. Again, going back to the competitive advantages I spoke about for rail. All the cities in Europe, the vision is you can almost go city to city anywhere within a couple of hours. I mean, that's just a fantastic ambition now. The interesting thing that's come out of that, and here we come to one of rail's weaknesses, if you want me to be frank, is that there are so many different types of legacy system. You may not realise it, but these days trains have very clever black boxes on them that allow them to talk to the ground, a bit like aircraft. And each country has its own different type of system. And the whole European project for interoperability relies on standardisation. It's a very big project, and clearly that has to link in with different countries' upgrades, because it only makes sense to do that when you upgrade or renew. But the key thing that excites me about that as well is this, again a feature of rail. We tend to have quite small production runs. So for us, a couple of hundred trains is quite a big order. If you compare that to the automobile industry, where you literally get into millions, you can see the problems we have. And people sometimes unkindly say that every rail project's a bit of a prototype because we have these quite small production runs. Visions like this, where we start standardizing on equipment, suddenly open up the marketplace. So for us, the attraction of this is not just that we can get interoperability in trains across frontiers. We can start standardizing on systems and even subsystems, so we can start opening up the market. So that vision is very exciting. Which brings us back to London and the UK. Clearly within the national rail network, there is also a huge demand, and we're looking at around over 22.5% growth there over the next 10 years. The key thing about us, though, in the underground is that as well as that, we have the interchange stations. We have these busy interchange stations, Victoria, Paddington, Euston, Liverpool Street, Stratford. So all that capacity that's been grown on the main line, 70% of it comes to in or out of London. So we're as much a mover between the various routes as we are anything else. You spoke earlier on, Lord Brown, about London. It is a world city. It is the premier world city. It's ahead of everywhere else. It's now recognised as the world city with all the different cultures here. It's also the gateway to Europe, which makes it very attractive. It's the financial powerhouse of the UK. But we think what makes us unique in the underground is this. We have this unique proposition of customer service. For us, because of our heritage, we are so proud of the way we serve the public and our customers through information, communication of everything we do. You may have seen the animation you came in. I wanted that shown deliberately. It tells you, as our customers, what we are doing is rebuilding that tube that you recognise. You all know the tube map, and it tells you, please bear with us, we're working on it. It's not easy. We always try and communicate to our customers. It's a very important part of what we do. But information, caring for our customers, providing personal security, and you'll see this when I talk about some of the features on our new trains, is something very close to our heart. Clearly we're not a Hong Kong where it's sort of about 30 years old. Our legacy that I start talking about soon goes back hundreds of years. So we can't compete on modern assets yet, but we will soon. We believe when we get our assets replaced with that strong customer heritage, we will truly be a world-class railway. And that is our ambition, and it's nothing less than that. But on these ageing asset base, we have this growing demand picture. The demand is driven largely by three factors. The first one is employment growth. We are seeing over the next 10 years employment growing by around 900,000 jobs in London. The second thing is population growth. We're seeing around 800,000 more jobs coming into London in the next 10 years. And then there's this interchange issue. That's a picture of one of our stations. I think that's Liverpool Street, where there's this constant through from the main line to the underground, to the central line. And those three factors have now resulted in us every day moving more than 3.5 million people every single day. And I can tell you it's such a responsibility to wake up every day and thinking that's the equipment that's moving them, the safety, reliability of that. It's a huge undertaking, which is why the teams of people who are here today who work on that deserve nothing but the highest praise. Let's look at how that demand has changed over time. You can see here, in terms of how many passengers we move, that we've gone up significantly over the last 10 years by around 25%. You know, few other industries can cope with that kind of demand. We haven't changed the infrastructure much in that time. In that time, we've added an extension onto the Jubilee Line. Okay, so it just gives you an idea of how intensively we're working our assets. The response to that, before we get the line upgrades, and boy do we need those line upgrades. Those line upgrades for us are our lifeblood. They will keep us going. The response to that is we've increased the number of trains we run. Put very simply, what we've done is the peak periods we have, say it was between 7 and 9 o'clock before, now starts at 6 o'clock and ends at 10 o'clock. And in that period we put more trains. That's our response. We just run more train kilometres. So again, you can see over the corresponding period we've grown train kilometres by around 20%. But clearly what that also means is our trains are more crowded. You can only do that for so long. And the capacity of the system, the underlying capacity, just won't allow us to grow it by that much. So the only way to get growth now is to invest in these line upgrades. I've talked about our heritage and our legacy systems. This slide always intrigues me. This is a section, this is the world's first metro. This is a section between Farringdon and Liverpool Street. It was opened in 1863. It is the world's first metro. I think that's Baker Street, actually. And you can see there, I think there's a steam train coming in. Boy, how times have changed. And we call this, by the way, our Subsurface Railway. Again, it's important because you'll understand later on why the Subsurface Railway is so important. The reason it's called Subsurface Railway is in those days, because London wasn't so built up, you were able to essentially excavate the ground from street level, put in these arches and cover it. And on top of that, literally a couple of feet above that, you might see the streets. That infrastructure is there today. Now that subsurface railway has two features. One is, you can see here, it's quite wide. You can get bigger trains. So those of you who travel on our trains, I guess most of you do, you'll find things like the District Line, the Met Line, the trains are nice and wide. When you're boring underground, every single inch you go wide, it costs you literally hundreds of millions of pounds. So there's always that trade-off. Anyway, that's the subsurface railway. Soon after this opened, we opened the entire Circle Line. And then after that, we opened the world's first electric line, which is between the then southern suburbs, which are growing up, and the City of London. That's still in place as part of the Northern Line today. Interesting thing if you look at the underground map. This is the map of the underground in the 1930s. Now, this is an interesting, for me, and hugely inspiring piece of engineering. This was designed by somebody called Sir Harry Beck. He's iconic in the underground because there's so much this tells us about good design. He was an electrical draftsman in the 30s, born in North Finchley. I think he designed this when he was in his 20s. And his only tools, he was an electrical draftsman, were straight and 45-degree bends. The map of the underground then was this sprawling, hard-to-read map. It was to scale. You know, engineers love drawing scales. And it was to scale. But the trouble is, our customers couldn't understand it. If you wanted to know where to go, how on earth can you communicate that? This comes back to the heritage we've got. We constantly think about how do we communicate with our customers. So Sir Harry Beck used his basic tools. He sort of did this a bit like a wiring diagram, which it looks like. And he essentially shrunk the suburbs, because they were all to scale, and he expanded the centre, and he made every line unique. And this map, he had to persevere. People didn't like it. They said, no one will look at that. They won't understand it. But he persevered. Another good example for us in terms of engineering design. And the map was eventually adopted and has changed little since the 30s. The major additions for the train spotters amongst you, and I was checking this before I came, mainly on the east. The city and the west are largely the same. Obviously you don't have the Jubilee Line to Stratford, you don't have the Central Line extending to the east and Essex, and you don't have the Victoria Line. Those are the major omissions, but at the centre and to the west, very, very little change. The number of people who use the network in those days, significantly less than 1 million a day. Significantly less. I want to now talk about the assets that underpin this operation. We do carry huge numbers of people. People often say to me, what are the key assets? There are lots of different asset groups, but and I know as soon as I don't mention an asset, I'll get people coming after me saying, David, why didn't you mention my type of asset? But nevertheless, in a speech like this, I have to narrow down a little bit. There are core assets on the railway without which you just simply cannot operate. They are the heart and soul of what we do, and I'm going to talk a bit about them. We have track, we have signals, which I'm going to talk about, trains, we need to get back to depots. Radio for us, especially since 7/7, has taken on a huge significance. The ability to communicate is probably the fundamental thing, especially in underground railways, for reasons I'm sure you'll understand. And stations. Key thing about stations, we have about 270 stations, of which about 120 are underground. When a station is underground, unless the lifts and the escalators and the fire equipment work, you have to shut the station. If we shut our stations, we cannot operate because people get on a network to get off at Tottenham Court Road, at Bond Street, at Euston. So for us, keeping those assets going in stations is as important as running the track signalling rolling stock. They all have different characteristics. Trains, for example, get back to a depot each night. So the good thing about that is you can have a crew who wait to receive the train at night and they can check it. All our trains tend to go back every night. We have stable one or two for operational reasons, but most of them go back every night. So that logistically is a nice, simple job. They go home, they're checked, they're fed and watered, as I call it, and out they come the next morning. The assets, though, that are distributed, the track and the signalling, we have to get people to them. And that drives a key constraint in everything we do, access for maintenance. I'll come on to that later, but it's just important to maybe just remember that thought for a minute. Some of these assets, you've got to get people there. They don't come home. They stay there. They're fixed. I want to tell you a bit about the age profile of some of the signalling, and we're going to start getting into railway signalling in a minute, which is always interesting. Here's the age profile of our signalling. You can see there's some new stuff. Central Line is red, the Jubilee Line renewed reasonably recently. But look at that. Nearly half of our signalling is 40 years or older. So, for example, in there somewhere, there it is, East London Line, that's Shoreditch, commissioned in 1943 during the war. And we have this mix of technology. We have relay technology, We have mechanical lever frames where people literally pull levers to set routes. And on the more modern stuff, we have processor-based. So we've got this wide mix of assets. So if you look at our competence and our qualifications, we have to have people who are competent across that array. For us, obsolescence is a real issue. Funnily enough, it's as much an issue on the new stuff as it is on the old stuff for different reasons, because the modern stuff changes so quickly you can never keep pace with it. But this old stuff, trying to get people who understand the lever frames, the program machines, is a real problem. We cannot keep going with these old assets for very much longer. So we have to renew them, which is why for us the line upgrades are so important in terms of what we do. We're now going to get into some interesting stuff about signalling. LU, we talked about Harry Beck's map, but we've pioneered some fundamental railway engineering. This is really interesting, I think. I hope you agree. But I'm sad like that. This is called a train stop. See that thing there? That's a train stop. Why is it so important? It's our basic train protection system. You need train protection on railways because with the best will in the world, drivers will go through red signals. It does happen and you need a protection system. And this was pioneered by LU. Here's the train stop. When the signal is at red, that's a green aspect, so that says the driver you can proceed. When that is a red aspect, that is up. When it's a green aspect, that goes down. You can see this. You stand at a station. We often have these at stations. Just watch as the train's coming in. You'll see the train stop going down. Then the train leaves, it goes back up. Okay? By the side of the train is a thing called a tripcock. And if a train tries to go through red signal when that's up, it clouts that and applies the emergency brakes. It is a fantastically simple system, but I can't tell you how well it has served the underground. And we still rely on this on most of our lines today. But here's the downside of this system. Just look at that infrastructure. And don't forget there's 5,000–6,000 of these are on the network. Every time one of those fails, when you hear there's a signalling failure, it usually is something in here. It's a huge disruption. I was going home last night, and it was a minor disruption on the central line, but it just felt like the world had ended. The platforms filled up, people getting huffy and puffy, the trains were crowded, everybody was hot. We just don't have the capacity. So for us, even minor delays become very big perturbations. The system is very intolerant now of minor failures. The infrastructure, so that's a train stop, that's the air supply that drives it up and down. It's mounted on or about the tracks, the P-way there, the ballast and the subgrade. If that fails, floods, that goes. It needs power and strategically placed just for this slide. Look, there's a bit of litter there. I asked them to put that in specially. Any of these things, if they fail, causes that to fail. So signalling engineers always get frustrated because 9 out of 10 signalling failures are nothing to do with the signalling, they're to do with the interfaces. Yet that is such a single point failure prone system. What we are trying to do is get rid of all of that. And what you'll see later is that is being replaced with modern processors on trains. All the signalling is going on the trains. That for us will be such a huge step forward, both in terms of cost, efficiency, reliability and safety. I want to tell you something else about signalling as well, because again I find all this interesting. A basic concept of railway signalling, this is the building block of railway signalling, is what we call the track circuit. I guess half of you probably have heard of track circuits, half of you haven't. The track circuit, what we do, these are the two running lines, these are the two tracks, okay, train sits on here. You divide the track into, roughly speaking, 500-metre blocks. These are called fixed blocks. Important concept, remember that, I'll come back to that later. Fixed blocks. So we have a fixed block here. That's essentially how you chunk up the railway as you're designing it. Effectively, the more blocks you have, the more capacity you can get. We apply to that track circuit, so interestingly, we use the running rails also to run our signalling current through them. So a failure of the rail, like a break in the rail, is also detected by the signalling system, which is one of the functions of the signalling system. But it also means, again, the signalling system is very susceptible to track failures. So we apply typically about 10 volts AC through a capacitor, which you can turn up and down. We don't like it very much, but people do it. And it goes through there. There's what we call a double-end vane relay there. If a train then occupies that track, guess what happens? It creates a short circuit. Short circuit through the interlocking sets the signal behind the train to danger. Very simple concept. So with the combination of the train stop and the track circuit, you've suddenly got how to signal the railway. Simple, but the people who invented this and who pioneered it think about what, and we still use all of this today. The majority of our track circuits are still these AC-fed 10-volt double-end vane relays. A relay, by the way, is a nasty piece of work. These are glass-enclosed relays. You can't do anything with them. They either fail or they work. You can't maintain them, you can't get in them. We're trying to replace them. But nevertheless, that's the rich legacy we've got. So, with that, you can see that the track circuit and the train stop gives us our basic signalling. I want to talk a bit about our cab environment, where we put our drivers, the people who are accountable and responsible for about 1,500 people behind them. When our trains are crush loaded, that's about the number of people they carry. Cab environments have changed over the years. From my train systems engineer, Malcolm DeBell, who I think is here tonight, I got some of these slides, and Graham, thanks. So here we have a cab of the sort of 20s vintage, you can see there, and Malcolm was telling me even the windscreen then was an innovation. We used to drive without windscreens in the old days. But look at that, lots of pipes and stuff, very mechanical levers. Around the 50s and 60s we started bringing a bit of innovation, a bit more electromechanical, but still quite clumsy. And just look at the way the driver's on top of it. He has to look out of the cab, he has not much in the cab to help him really. He drives it with a dead man's handle and the traction controller and off he goes. He has to look outside to the signal. He has to check that when he stops he has mirrors to look back and make sure that the train is, the doors are shut and no one's stuck in the doors. Responsible job, but he has to do it all manually. We've tried to change all that. We've got two kinds of cab here. This is what we call our sort of typical 90s generation cab. This is the kind of train we've got, the Central, the Northern, the Jubilee. All came in the 90s, all a similar type of cab. And you can see here a totally different system. We're now getting processor-based. We're thinking human factors. That's science that now thinks about how people work, where they have to reach to, how they sit, what their workload is, what tools you have to give them. And we've started to put some automated tools in there. So, for example, the driver now sits further back because he's looking as much at the controls in front of him as he's looking outside. In here he gets his CCTV, so he doesn't have to look at mirrors. That's now relayed into the cab, split screen, full screen usually. He has a train management system that tells him whether the train's healthy, whether it's got a problem, whether he needs to report it and take it into the next depot. So the train constantly manages itself. We try to air condition as many of our cabs as we can because the drivers are in there 7-8 hours a day. So, you know, how would you feel if your office was hot and stuffy? We'd like to think about it that. I often travel in with these guys in the morning. The last thing I say to them is thank you for having me in your office. It's their environment. Treat it with a great deal of respect. And increasingly we're putting the signal in the cab. I'm going to come to that later. And here's what the cab and the trains are bringing on the Victoria Line is going to look like. And I suppose the big piece of innovation here, and you may laugh at this, and it's pretty fundamental, that's left-hand drive. This is right-hand drive. Most of the platforms on the Victoria Line are on the right-hand side as you come in. So we took the huge leap of moving the cab from the left-hand side to the right-hand side. So that should help. And we've cluttered, less clutter in the cab, more advanced change management systems, the signal will be in the cab. So a bit of innovation there. But our stations are also world-class and stunning. Here's the Jubilee Line Canary Wharf station, which I had the privilege to be involved in the 90s, designed by Sir Paletti. Fantastic, fantastic stations we've got. I mean, these are just cathedrals. These are wonderful, wonderful stations. So what a lot of people don't realise is the back-of-house stuff. Canary Wharf, there are over 300 rooms with equipment in to run that station. Okay, these are huge undertakings, these stations. The big thing, though, about these stations, they were built on a greenfield site. We do not have that luxury anymore. So keeping the railway operational during construction is our big challenge. I talked about the upgrades we're doing that we have to do while we keep the railway operational. This is a slide that tries to communicate to people the scale of what we're doing. So as well as those numbers, as well as moving 1 billion passengers a year, this is what we also have to do. We're doing the line upgrades. Every single line on the railway in the next 10-15 years will get new trains, new signalling. I'll come on to that. We're replacing our radio systems with a brand new state-of-the-art digital radio system. We've modernised so far about 90 stations delivered into service. Remember what I said about the big interchange stations? We absolutely have to do those. These are the big interchanges: Paddington, Euston, King's Cross, Liverpool Street, Stratford. We have to make as many of our stations step-free, that is, for people who are mobility impaired. We've got a commitment of 25% by around 2010. A huge step forward for the underground, because those of you who may have travelled with people who are mobility impaired, whether they're in a wheelchair, whether they're carrying a kid in a buggy, whether they've got a limp or whatever, it's difficult to get around. We understand that, but it's our legacy. We are trying to attack it. So that's a big programme itself. We've got the whole tunnel cooling programme. I'm going to talk about that, so I won't steal its thunder. We're taking over stations on the Bakerloo line north of Queen's Park. They're coming to LU control, so we'll be staffing those. That's another big programme we've got. And we're commissioning the systems to Terminal 5 around the middle of next year. And on top of all of that, we have to now restate our terms for the periodic review to say for these contracts, the public-private partnerships, what is it we want? And so we go through the repricing process. And on top of all of that, the first real test of us as a world-class railway, the Olympics in 2012, we've already started the journey with Stratford. People often say, so how are you organised to do all this? How does it all work? I can't get my head around all this PPP, PFI, so here's a nice simple chart for you. And believe you me, this was the simple one. Effectively, London Underground is a subsidiary of Transport for London, so on that holding company chart, you'd see London Overground, buses, streets, etc., lots of different companies. London Underground is the operating company for TfL for the underground system. We have effectively 4 major arms of delivery. Okay? We have the private finance initiatives. We buy power, for example. We don't make power anymore. The underground used to make power. We buy power. We have totally outsourced our power. We buy it as a product. So that's the PowerLink PFI. We're buying a radio solution, a communication solution from CityLink and Connect. And we bought a lot of the ticketing services from Prestige. The second layer of delivery is third-party projects. Interestingly, around 30 or 40 major projects where people like, say, Westfield at White City want to put new stations on the underground because they're putting a complex nearby. So that involves a lot of work, depot sidings, trains for accommodation. We try to work very hard with developers. We understand that developers often find rail bewildering and unfriendly. We can understand that because from the outside it looks this complicated, hierarchical, compliance-based, rule-based culture. So we do try and work very hard with the suppliers and pull them through and work with them. And I guess most of them these days are saying, yeah, it's not so bad to do business with you, but it still needs to get better. We recognise that. The third arm we've got is the TfL direct investment, where TfL is saying, on top of all this, there are things we know we need to do. And the 2 good examples are the step-free access I spoke about earlier on and cooling the tube. And the final part of delivery, which is fundamental to the line upgrades, are the public-private partnerships, the PPPs for short. We've got 3 tube lines to do the Jubilee, Northern and Piccadilly line, and the 2 arms of Metronet, one doing the Bakerloo, Central and Victoria line, the other one doing the Subsurface Railway I spoke about. But on top of all this, we desperately need Crossrail, and it was such a great announcement last week. I mean, it was like the Olympics all over again. Such a big step forward for this city that Crossrail was announced, this £16 billion programme, and the central section that goes through London obviously has major interfaces to our tunnels and also to our stations. This comes on after the line upgrades. If we don't do the line upgrades, this will not solve the problem. The base case for Crossrail is all those line upgrades are done, because this comes in after those line upgrades. The central section is being delivered under TfL because we need to manage the whole interface stuff between the PPP and Crossrail. But for us, it's just such a fantastic thing. We're genuinely over the moon that Crossrail is starting. With all these projects, though, come back to our core value. This is all interesting. Well, we've got to move 3.5 million people every single day. We've got to do it without disrupting the service. So we are absolutely obsessed with reliability, performance, how we manage time, how we manage access. Reliability for us is a key issue. There are lots of techniques we're using to control reliability. Here's just a sample of them. A lot of these come from the work the Infracos are doing. The first thing one of the recent innovations, actually, Metronet should take the credit for this, is visualization. It is such a complex array of statistics, assets, locations, faults. It just gets bewildering. So what we've done now is we've got what we call war rooms. So for each line, you can go in there and you can see on the wall charts that tell you what the problems were with, say, the track circuits or the train stops, when they last failed, critically what needs to happen tonight, and then on the next chart, what happened last night that then needs to roll into what happened tonight. Everybody can go there so we can at a glance see what's going on. The other thing we're trying to get into is reliability-centred maintenance. That is a different way of looking at maintenance. Traditionally, maintenance is around safety, minimum safety. What we're now trying to do is say, well, we need to do in some cases more because we've got these assets. If you look at those train stops, for example, reliability-centred maintenance says go and maintain it more often because the concept of failure, although not a safety issue, is such a reliability hazard. To do that, though, we do need to do a lot more work on understanding our asset condition because the legacy of this infrastructure is such it's so old, the records weren't there. We really need to understand the relationship between input and output performance. One of the big things in rail that we're trying to get rid of is this concept of no fault found. That is, there is a failure, people go there, and they say, well, we couldn't find what was wrong with it, we stood there for an hour and we left it and came back. None of us like that anymore. We want to get away from that. And we do quite a bit of work in LE with BA, and I knew the Director of Engineering at BA, It was fun because he let me go there and sit in his 747, so that was always a good reason to go and have a look. But they have this culture which I found really, really inspiring, which is they hated no fault found. A fault on an aircraft could be the one, no matter how small, that caused it to crash. So for them it's a matter of professional pride not to have a fault that just lay there. We're trying to bring that culture into rail. It's taking some time. We are gradually reducing, though, our no fault founds, but it was at too high a level. It was at too high a level. And for our new assets, we have to be obsessive about designing in new reliability. One of the things about rail is this is asset intensive. Our assets last for 40 to 100 years. Decisions we're taking today will be with our children and their children. And I feel duty-bound to always try and get the best deal I possibly can. Look at the legacy we were left by the people who opened the subsurface line, by Beck, by the signalling pioneers, by those trains. What a great legacy that was. We need to make sure that the new kit we're designing, we're leaving that legacy too. So we are looking very, very critically at the designs of our new trains and new signalling about reliability. And one of the things we do is we do not allow kit to be brought onto the railway unless it has passed what we call reliability gateways. We look at the underlying equipment. I come on to it later. It's very rare that you just put new equipment on the railway. It has to work with the old equipment for quite a while. You stage it. And we try and predict what the impacts of the new kit is going to be on the old kit. And usually it means the new kit has to be super reliable, just because otherwise, if it combines with the old kit, it will fall over too often. And we do have these reliability gateways. And we track performance. So, for example, if you were to come to our organisation at 8:30 every single day, you will see from Tim O'Toole to Mike Brown, to me, to Richard Parry, the key directors of the company, we sit round and we go through in painstaking detail every failure on the railway the day before. Every single day. Every single day. And that sends a strong message. We have found it so powerful. It says no matter what happened on the railway, we want to know what happened. Why did it take so long? What happened when you got there? Why didn't you have that bit of kit? All of us are really demanding of each other on that. And that is a way of sending out a message from the top management. We care. And why do we care? Because it's our customers. They want to know that we're worrying about that. They want to know if they're disrupted on their journey, that somebody's going to be calling it to account. So, the other thing that we have is this concept of time. Time on the railway. The currency, I mean, obviously we have lots of currencies. Money is the obvious one. People is the obvious one. And that is our most precious asset. But the other big currency we have is time. We just do not have enough time in the day. So managing access for us is a real issue. There are, in London, 11 football teams, for example, 7 of them in the Premiership. Just multiply that through a season. How many times you have to lay on special trains, special services for a football match when you should be ramping down? I always say there are 4 things we need to do on the railway in terms of time. And I say this to people who say, why can't you let me test my new system over 3 weekends? Why can't you let me shut down the line for 4 months? Very, very simple, because we care about our customers. Remember what I keep saying? Our heritage is about our care for our customers. They come first, second and third. There are 4 things we do with our time. The first thing is we operate the railway. We move those 3.5 million people every day. The second thing we do is we have to do a lot of special events. It's growing all the time. We have to book these a year in advance. So you get sort of this very fixed constraint in the calendar. You literally cannot move. So all these people have to plan, do publicity, all that kind of stuff. Then we have to maintain the assets. Remember what I said? People have to go out and look at the track. We patrol our track regularly, look at the signalling. Okay? And they have to do that in the literally 3 or 4 hours there are each night to do that. The time that is then left is for the 4th thing, which is to upgrade the new systems. So straight away we've got this huge constraint, which is the access time on our railway is such a powerful commodity. And we value it very, very, very highly. So we're obsessive about time. And everything we do, we monitor time, we monitor how well it was used, monitor if we can do it more. The other thing you'll see when I talk about the upgrades is we've now invested heavily, all of us, in test tracks to try and get as much done off-site, because the concept of shutting down the railway just simply is not feasible. So, let me talk about the upgrades. Essentially, at the end of the upgrades, we'll have a total network capability enhancement of around 28%. That is massive. I'm going to tell you how we're doing that, and that goes all the way through. Here, we've started here, we've done the Waterloo and City, we've added a 7th car to the Jubilee Line. There were 6 car trains, we've added a 7th. That was a huge fillip for our customers, because straight away we've increased the line capacity there, and we're now in the middle of putting in the control systems right the way through. The Vic line is ongoing. I'm going to talk about all of these. What is involved in upgrading? Well, statement of the obvious, but nevertheless hugely important. We get trains, we get signalling, we get track, we also get more power, and we've got to do this in a way that doesn't increase the problem we've already got, which is our tunnels are very hot. And we have to do it in a sustainable way. Going to talk first about the Victoria Line. This was the world's first automatic railway, another first for London Underground. Why was it automatic? Lots of reasons. One of them is, and this is an interesting fact on the Victoria Line, we've got many more trains than we have platforms. So if you think about it, when you're operating this railway, at any one time there are trains between stations. That is a problem that you need an automatic system to try and get you around. That's why one of the big drivers for the automatic railway. There's the Royal train, driven in 1969. The trouble with being the first on having an automatic railway is we are now the first to have to renew an automatic railway. No one's done it before because we were the first. So this thing about being the first is a bit of a challenge. Lots of benefits to customers though. I mean, look what we're going to be able to give our customers, because that's why we're doing this. Customer first all the time. We're increasing the train capacities. I'm not going to read all those stats down, you can read them. But you will see a significant uplift in the capacity and the comfort of the Victoria Line. The trains start coming in towards the end of next year. We're testing them already. We start introducing new timetables. The trains are assembled by Bombardier in Derby. It's interesting the way trains are made these days. It's not so much a manufacturing base anymore, but probably like most sort of mechanical electrical things these days, it's a system integration assembly line. Most of the subsystems on the train, whether the doors, the body shell, the cab, the traction system is a traction system being dropped in, are made elsewhere. They're brought there as units. So the assembly line takes all these units and makes it into a train. So you can imagine the huge quality assurance you need there to make sure these trains have to go 40,000 miles between casualties. Okay, given all the complexity on them, that's many, many times more than the existing trains. Okay, and that's what we're getting for our customers, because one of the bits of feedback they give us is that we love your underground, we hate it when it breaks down. We don't like being in those hot trains. We care about our customers, so we've said to our supply chain, you must make these trains reliable. So that's a target for these trains. The train is then tested on the test track. We've invested in a test track. This is in Derby. And you can see, well, you can't see actually, we've installed the signalling on the test track. I'm going to come on to the signalling, a very, very important part. Because this is an automatic railway, we can't actually use these trains, so they've had their black boxes installed on them. The trains on their own, frankly, are no use. It's trains plus a black box. It's a big integration challenge there. So we test that in Derby. We do as much as we possibly can at Derby. Yet there are still tests you need to do on the railway, what we call application tests, things that are unique to the Victoria Line, things like electromechanic capability, simple things like gauging runs, okay, and it takes time. Remember what I said about the time, a couple of hours each night if we're lucky. We communicate to our customers. One of the things they've told us is, tell us when you're closing the line down. This is a poster, interesting how many of you here have seen it, but it's on most of our cars, and the feedback we had from our customers when we've asked them is, did you understand why we closed the line down? And they say, yeah, we understood. We know you're upgrading the railway. We want you to. We were able to plan our journeys, so thank you. So this business about communication for us is so important. It's so important to take them along with us on this journey. So these work quite well. And here's the train being tested on site. First arriving at Northumberland Park Depot, and then out there with the teams going through its tests. This is what we call T1. It's the first train. And, you know, it's going quite well. Obviously a few issues we're picking up. But it's a good train, exciting train. I'm going to tell you some of the features in the train. First thing you'll notice, we've got a lot of customer security improvements. Our customers have told us we love travelling underground, we feel safe, we feel cared for, but can you give us a bit more? So we put some new features in here. So for example, we've lengthened this window so you can see through, so you don't feel so constrained in a cab. We've got door lighting, so when the doors open you'll see lights coming on for people so they can see where they're going, managing the platform train interface. And we've got better passenger emergency alarms, what we call PAs. If it comes up, there it is. You remember on some of the older trains, it's something you had to pull. We've made it easier to see. There's a trade-off, though, here. If you make these things too easy to be activated on crush-loaded trains, people go up against them. We have quite a few trains where it's an accidental activation of a PEA. So there's always this trade-off between comfort and reliability. And those are also linked to the CCTV. So if somebody activates one of those, the driver can see what's going on. We've also got much better customer information. What our customers have told us, we love your underground, but can you give us more information about what's going on, especially when there are delays? We've listened. We're putting all these enhancements into the trains. So what you can see here, there'll be 6 of these screens in each car, and it will show sort of the section of the line you're travelling on. It will tell you when you're coming to an interchange station. It will tell you, because it's got real-time communication now between these trains and the clever control systems. It will tell you if there's a delay and tell you what to do. So, enhancements. But for this line, given the scale of the time, remember, as soon as the PPP signed, we almost had to go into production to get these dates. We did largely use tried and tested technology. A lot of this is innovation to the underground, but it's not innovation. We had to manage it quite tightly. There's always this trade-off between time and innovation, and what we wanted to do here is not push it too far. At the same time as doing this, remember the slide I showed you, all the stuff going on, we're doing the Jubilee line as well. But first of all, I just want to tell you about the clever stuff. This is the really clever stuff that customers don't see, and this is the really exciting stuff. This is innovation. This is a picture of the technical architecture. Looks complicated, but very simple in concept. Here's the train. We have on the train computer and telemetry systems so that the train knows exactly where it is, how fast it's going, its limit of movement authority, the speed it should be travelling at, its destination. And it does that through a combination of black boxes, telemetry systems, positioning systems on the train, for example, using radar systems on the train. Doppler radar is being used for the first time in the underground. Tachometers that count the revolution of the wheels that work out. These two off constantly compare and contrast and say, do we check OK, do we check OK, do we check OK? That's how you get the integrity levels up. And these communicate to the black boxes on the train. There are two major black boxes. One is an automatic train protection box, which is essentially that train stop I told you about, now put in software. Well, there's automatic train operation, which is essentially the driver's day-to-day tasks. This does the driving for us. And those things drive the train. It communicates through a radio system to the track side. And in each room of the station, stuff you don't see, remember I told you about all those rooms you have to have at these stations, we've installed a lot of signalling kit. There's a very clever central control system as well. Remember I told you about managing the number of trains and platforms. That requires a degree of cleverness in the central control system. Here you can see a picture of the installation in the rooms, and you can see this is just a typical room. Just look at the amount of wiring, communications, power supplies and computers. This is in each room of each station on the Victoria line. That stuff constantly communicates to the train, constantly communicates to the central control system, and constantly works out how to regulate, how to go faster, how to catch up, when to stop, what the timetable is, what the speed is. So, pretty good stuff. At the same time as that, we've got to do the Jubilee line. The Jubilee line is being upgraded end-to-end, Stratford to Stanmore, with a fantastic new system that I'm going to show you a bit of a movie on. Essentially, it works on a moving block process. We're in the final stage of commissioning, and we're now starting to commission the first area, so we're really excited about this. We've already added the 7th car onto the Jubilee Line train. We've again invested in off-site testing. Here's the test track at Highgate in London. Remember the other one was at Derby. Very similar thing. We've installed the signalling, put the loops on the track, installed the stuff. This is the computer on the train. This is the train reading stuff, the positioning reading stuff. And a lot of tests are being done here that in the old days we had to have done on the track. But remember, we've said to our people, our customers value our time. So invest in test tracks. And that's what we've done. I think this now works where this movie starts, I hope. There you go. This is the way moving block works. We don't have fixed blocks anymore. Remember I told you the way the track was chunked up, done away with. The signalling is on the train. Remember all that telemetry, all those computers, it's constantly working out where it is, and it essentially moves relative to the train in front of it. There's a safety distance there, which is in violet, and it cannot breach the safety distance. As the train ahead is slowing down, you'll see the safety distance shrinking up because it's a function of speed, but it's constantly working out, where's that train, where am I, where's that train, where am I, how fast can I go, where do you want me to go to? Stops at the safety distance. As the train moves, the driver doesn't have to do anything, you don't have to wait for signals to clear, the train works out it can move again through all this clever stuff, and off it goes. Very, very, very clever stuff. This allows us to get much more out of our fixed infrastructure. The big challenge we've got is we've got this fixed infrastructure, and we can't do deep tubes. We have to squeeze the most trains per hour we can, and we're using this modern technology. I now want to talk, at the same time we're doing all these, I now want to talk about the Subsurface Railway. The Subsurface Railway is effectively the Metropolitan line, the District line with its 2 branches to Richmond and Wimbledon, so the Hammersmith line and the Circle line. That's the Subsurface Railway. Remember their characteristics, just below the street level, wider. Remember the wider and just below street level becomes pretty important in a minute. We started design work on that. We are getting wonderful new trains. We have a bit more time to innovate on these trains. They don't start coming in till 2009, till about 2014. These are going to be a really, really breathtaking experience for most Londoners, because this is a new train. Two key features. We have through gangways, so you can see literally from one end of the train to the other. Creates much more space, easier to manage. And secondly, because it's subsurface, we can get rid of the heat that is otherwise generated by putting air conditioning on trains. So these trains will be the first on the underground to have air cooling. So for our passengers, for our customers, this is going to be a fantastic step forward, and we're really excited about this. They start coming in around 2009 on the Met line. Again, we're investing in a test track. This time we've bought, with Metronet, the test track that was used for the testing the trains for the West Coast route mod. This is in Old Dalby, which is in Leicestershire. And we're going to equip all these lines with the signalling. We're going to get the trains up there, and again, we're going to do all the tests up there that would otherwise have been done on the underground. Why? Because we cannot shut the railway down. Just a few hours each night for testing. One of the key things I've spoken about is software. Software for us is a big issue. It's not traditionally been a railway engineering core competence, but you can see increasingly amounts of our stuff are being done through software. We've had to become more competent, more aware. I have to say it's a devil of a thing to manage software. You can't see it, it's ethereal. So what you have to do is become obsessive about metrics. How many tests? You have to keep asking, when did they fail? How many verification tests? How many rebuilds? How much regression? You become a software expert overnight in this business. It is safety critical because it has to be. You can see what we're asking it to do. We're asking it to safely position and move those trains and manage the entire railway for us. It's got to be very reliable, very reliable. And a critical concept in railways, which is a funny term I know, graceful degradation, is a requirement of all our software systems. That means if something fails on the train, it has to be able to at least go to the next platform, even if in a slow mode. For us, that's a very important part, because our customers have told us we really don't like it when the trains fail and we're stuck in a tunnel. So we've made that a requirement. High reliability, and if it does fail, put a system on the train that you can at least move it into the next platform. Get it out of danger, bring it home. Interesting, obsolescence is as much an issue on this new stuff as it is on the old stuff, because we find that they're constantly talking about new platforms, new languages. So a key factor for us going forward in terms of managing the whole of life is equipment refresh. Plug and play. We're looking for that kind of stuff. It's also a feature of our new radio system, which we call Connect, for obvious reasons. I talked about 7.7, and the huge issue in 7.7 was the ability to communicate between drivers, station staff, depot, control rooms, emergency services, incident response teams. We've got a load of different systems on the underground at the moment that don't talk to each other. They're very unreliable, because they put it in the days when radio wasn't seen to be a fundamental part of the railway. It is today. It is today, I can tell you, big time. So we invested and brought forward our plans to put this system on, and we're making absolutely fantastic progress. It's a great system, digital, based on Tetra trunk radio, and it's going in. And we've already put it in on several of our lines. It's in on the Met line, it's in on the District line, it's in on the Waterloo City and East London line, it's in on the Victoria line, and we're soon going to put it on the Pick line. So we are making significant progress. We're really proud of this, but for us it's so important. I now want to talk about another big challenge we've got, which is how to keep the tubes cool. A very, very big issue. And I'm soon going to run, I think, a video, but just a couple of slides first. Here's a map of the heat on the underground. Interestingly, you can see the subsurface bits bluish, cool. Why? Because they're wide, close to the surface, to get rid of the heat. The areas we've got issues are the deep tubes, Central, Victoria, Hotline, Bakerloo, Northern, Jubilee. That's where we've got a big problem, and we have to do something about it. We've started a programme funded by TfL. One of the first things I was given when I joined the underground was to get a grip of this programme, get a solution set. We've got some of the world's best brains working on this, I can assure you. Solution set, as ever in engineering, when you come back to it and go around it, is relatively simple. The first and obvious thing to do is, whatever you do, try and reduce heat and energy at source. Okay, so it ties in with very much the sustainable development agenda that I'm going to talk about in a minute. But the second thing is, the most cost-effective way of cooling people is to use air. If we can just move more air around, what our customers tell us is, when I'm in a train that's stuck, I just want to feel the air move. So we either increase the ventilation on trains, but you can't really do much. So what we're really investing in are these deep shafts. We've got a lot of shafts that have become out of service over the years, if I tell you over 100 shafts that weren't in service, that had fans just had fallen out into disrepair, we've installed a lot of those again. The third thing is we use water, the video will tell you this. And the fourth thing is we are using conventional mechanical chilling, air conditioners as you know them. So that combination, we now have a solution set for every station and every line. If we fire the starting pistol tomorrow and we are funded, we can do it. We're constantly innovating, trying to find better ways. We're starting on the Victoria line. Let me run the video because I think you'll find it quite interesting.
Summer in the city can be uncomfortable. Sometimes it seems the tubes can be hotter than the beach. But now we're doing something about it. Our team is working on beating the heat with a series of short and long-term projects. We have the oldest metro system in the world, much of it built long before air conditioning was invented, in small spaces deep down under London in the clay. Today there's little room for air conditioning in narrow tunnels and on busy stations, so we have to find other ways. The heat's mostly caused by our electric trains and people. 1 billion passengers a year generate a lot of heat. Sometimes it's not too much of a problem. But in the deep level tubes, temperatures have built up over a century as the surrounding clay has a sort of hot water bottle effect. Temperatures are rising. Our investment over the next few years means a better underground, but more and faster trains and more passengers mean higher temperatures. So we've got to act. Underground water is nearby some stations like Victoria, and now some of the water that we normally pump away 24/7 is being used in the station cooling trial. We're pumping cool underground water to heat exchangers in the concourse area, and it's working. Another plan is to take water from boreholes through pipes in the tunnels to cool stations. These are big engineering challenges and can't be done overnight. So in the short term, we're doing things like introducing industrial fans in places where it's particularly uncomfortable. And at Oxford Circus, equipment is being run into the ticket hall to cool the area around the barriers with air from chiller units outside the station. We're also repairing and improving the existing station ventilation network. Some of these huge fan shafts are more than a century old and may have been neglected in the past. On the surface, some may look quite elegant, but they're vital to keeping stations cool. We've more than doubled the number of fans in service, with more to come. Accelerating and decelerating trains create a lot of heat, but now the brakes are being used to generate more electricity, so that this energy isn't wasted. This regenerative braking is already being used on newer trains. On the trains themselves, we're looking at ways to improve the flow of air in carriages, and new trains coming in shortly for the subsurface lines will all have air cooling. We're also working on sucking heat from platforms and under trains into existing air shafts. And we're planning to trial something used successfully on the Madrid Metro, where air is passed over a wet pad or through a mist of cool air, so cooling the surrounding air. And another project will run cool water through pipes in the tunnels themselves, something that's already worked in the Channel Tunnel. Air conditioning on its own would only transfer heat from the trains into tunnels and stations. But fan shafts have been built in some of the newer tunnels, like the Jubilee Extension, to pump in cooler air. And of course, we're constantly monitoring temperatures and humidity across the whole tube network, so that investment can be focused on where it's needed.
I just want to talk a bit about system integration. It's it's so closely related to how we work with our staff, how we manage reliability as we go down this journey. I guess there's two important points I'd like to make here. Remember that slide I showed you about the train stops and the track circuits? Railways are pretty complicated system environments. Trust me, they are. The stations themselves are a big system, but on the main line, on the actual track itself, there are interfaces between the wheel and the rail and the platform to train. In fact, the platform to train interface, as we call it, i.e. that interface where customers get on trains and off, is our riskiest place. It's why we put a huge amount of effort into trying to manage. Screen doors are the obvious example, for example, on Jubilee Line. We're trying to make the business case for more, but it's hard work, frankly. It is hard work. So we just have to try and manage it through procedure. We've got electromagnetic compatibility issues with new trains and track circuits. The track circuits I spoke about earlier on operate around 33 1/3 hertz. AC, modern trains with their AC motors don't get on with that very well, so we frequently have to immunise. So we have to do a degree of signalling just to bring on new trains. And obviously we have the whole interface to power and timetables and the tunnel cooling programme and the signalling system. So complicated old system pictures. Here's a schematic I used to try and explain, then I'm going to come to a real example. The key point here is this. This complicated system is held together by the engineering system and the operational system. And if you just make one change, either to the operations or to the engineering, you run the risk of uncontrolled change to business outputs. These upgrades I'm talking about will not be brought in overnight. They won't be brought in as one lump. People won't just turn up and say, right, here's a black box, turn it on. They will be brought in over several hundred of these stage works on each line. I say, and I've been involved in quite a few of these, and I say to people, it feels like trench warfare when you're in it, and we're in it now. Every day, on every line, there'll be a new stage work coming in. Our role is to make sure that across all of those lines, we understand the impact, and we're assured that the outputs can be achieved. There are lots of techniques for this. We manage the interface, we map the interfaces, we have very complicated technical architecture diagrams for our lines. Just imagine the faces on the black boxes on the trains themselves, the power, the timetable. But I want to talk to you to bring this to life through a specific example, which is the Subsurface Railway. And here's an animation that kind of shows where we get to. At the moment, and given the history, the legacy, our rich heritage, the Subsurface Railway has signal control. That is not the signalling, but the desks at which people sit to remotely monitor which way the points are throwing, to remotely monitor where trains are, and to communicate to the drivers. That's what we call control. Controlled through a large number of different control rooms or signal boxes. Baker Street, Earls Court, and signal cabins all over the place. What we have to do, and this is just one aspect of that, is make sure as we migrate from these old systems to a single new system, each stage is managed. We know what the configuration is. We have to be nuts about configuration control. And we need to manage the staff because each stage may require new people trained in different things. It takes years to recruit and train signallers. We need different operators trained in different things. We need different maintainers. And critically, remember the access I told you about? Each of these stages may require a closure of the railway. It has to be booked years in advance. Yet, it is entirely possible, and probably will happen, that somebody will come and say, I'm sorry, the signalling slipped 3 months. So for us, we're obsessive about time and about planning. It's the way we manage this. Just want to very quickly run through this animation because I think it shows you what happens. This just is a testament to the planning that one of my colleagues, Paul Killier-Smith, has put into this. He's our operations lead on this stuff. But we first of all, at the north end of the Met line, has to put in an interim control system and transfer. Then that enables us to go to the final control system, and essentially every control area on the map is turned orange. Each of those stages requires people to be trained, communicated with, moved, the implications on the operation to be understood, and eventually that map turns entirely orange. That's just one example, and all this work has to be done now. Okay, although you see at the end it's done, the work is starting now. And that's the kind of planning we have to do. I think that's finished. On top of all of this, on top of the line upgrades, the planning, the network integration, we clearly have to do this in a sustainable way. It is a fairly new challenge that's been given to us. This wasn't around at the time of letting the PPP contracts. This is something that's happened to us in the recent past, and we have to be alert to it. The good news is that LU is already part of a low-carbon solution. We work with the Carbon Trust, and they essentially say, you are your own carbon reduction programme. In fact, the more people we can move on the underground, the better off we are. Yet, on the other hand, we have a problem because we're a huge user of electricity. You can imagine we're London's biggest electricity user by far. So we have a lot of buying power, and we need to be an exemplary performer in this area. So we have an action plan which essentially is around three major themes, one of which is energy sourcing. We already get about 80% of our energy from renewables, and we want to grow that, and we're working with the supply chain because we're such a big user we can leverage. The second thing is better design. You saw most of this on the Cooling the Tube video. The one thing it didn't talk about was coasting control. Coasting control is really interesting. We have shown that if we drive our trains, and remember it's automatic so we can control this, we can program it, if we drive our trains in a way that allows them to get up to top speed quicker and then coast for longer, it has a dramatic reduction on energy usage. In some cases 10-15%. So that's 10-15% less we have to spend on cooling the tube and 10-15% on our ever-growing electricity bills. And we can do that through our new clever control systems. The final thing, which again we're working on, is with our staff, trying to really embed the whole concept of being energy conscious. We're already saving through that kind of thing 14% of our station energy. So we're really working hard at this. Although we believe we're an energy efficient solution and a sustainable solution, we are still working hard. I'm kind of approaching the end now. I just want to talk about probably our greatest issue, which is our people, our resource. I'm an engineer. Most of you here are engineers, and yet we are facing a very, very significant challenge in getting the engineers of the future. And to me, it's the challenge and the opportunity I want to finish on. Here's one angle. Here's construction in London, and the thing to focus on here are the green and the red dots. These are big, big programs. Look at them now, and up to and around the Olympics. Huge growth. All of this will suck in engineering. We've done some specific work looking at chartered engineers, and here's the age profile of chartered engineers compared between 1988 and 2004. You can see the significant rightward shift in the age profile. We are just not getting enough new people into engineering. It's a big, big problem for us. And look at that. Just look at that. We train, on average, in this country around 14,000 graduates in engineering every year, of which less than half actually come into the profession. And just look at that low number of female graduates. That in itself is a huge opportunity. That's what I call my bucket slide. We do a lot of work with schools to try and encourage, to motivate, to mentor. I talk in schools, a lot of my colleagues do, to say engineering is a great thing, there are huge opportunities, and we give them a lot of this kind of publicity. Try and inspire them that this is a real mission we're on here to modernise this world-class tube. There's about 500,000, just under 500,000 kids at school read GCSE maths and science. About a tenth of that go on to A-level. That's actually not that bad, but that's the raw material you're starting with. About a third of those go on to become engineering graduates, and we lose over a half. They go to law, accountancy. I mean, the great news about an engineering degree is in demand, because you're numerate, you know how to work hard, you can think. It's high in demand. The bad news is so few of them come into the profession. But I'm pleased to say, working with Professor Matthew Harrison at the Royal Academy, we have started to make inroads to this. So we're working with schools. We are creating education packs for schools. I saw it yesterday. It's fantastic. It's really good. It tells kids about what we do, what engineering is all about. Half of them don't even know what an engineer really does. You know, they think it's the bloke who comes to mend the gas. We run ambassador and mentor schemes. We go to schools, we talk about them, we mentor kids. We say, you know, if you want to come in, spend a day in the office, learn about it. And we're encouraging this 14 to 19 engineering diploma at technical colleges, not just for people coming to become graduates, but also we need technician engineers too. We're short right across the piece. It really will hurt us unless we can do something about this. The universities were linking more and more with the graduate and postgraduate courses. So, for example, on the tunnel cooling thing, we have a very strong partnership with South Bank University, where we go and talk to the graduates. And it's so important to stop that loss between the 14,000 and the 6,000, to say, come and get involved early. Here's what you can do. Get them inspired. Don't lose them to other professions. And through our Infocos, there's a huge amount of investment that they have made, not only in graduates, they take on more graduates. We took on, I think, about 6 graduates last year. By the way, when I started at London Underground, we have stopped the graduate recruitment scheme, which is a cardinal sin. We've now started it again. But we used to be the recruiting ground for the entire industry. You find, for example, rolling stock engineers, there are only 2 places you came out of, British Rail or the Underground, and we'd actually stopped that. And it's a tap that you turn on, it takes years and years and years to come through. My rolling stock colleagues tell me it takes about 10 years to train a good rolling stock engineer. You know, it's not a quick fix. But we started, And the Infracoast have made these massive investments in the training schools at Acton and Stratford. You can see both of them from the railway. The Stratford one, as you're going into Stratford Station, look on your left, you can see this fantastic new training school. And we're growing the supply of apprentices and technicians. We have had a very big problem with signalling technical officers. These are people who go to the track and frontline maintenance. We have a very, very, very big shortage of those. But through this initiative, we're now starting to meet demand. And that's one of the great things about the investment that's been made. Okay, I've been talking for about an hour, which is amazed my voice stood up. I've been quite ill. So, I guess to finish, I hope I've told you about the enormous challenge, what we're trying to do. It's just breathtaking in terms of the complexity, the ambition. At the heart of it is our unique proposition, which is the customer is at the centre of everything we do. As an engineer, I have had to become much more attuned to the customer focus. Everything we do, we think about our customers, about how we introduce the kit, how we plan it on a network level, how we make it reliable, how we invest in test tracks. We have started delivery. We're making huge progress. We've done the Waterloo City Line. We've got the 7th car on the Jubilee Line. We're halfway through our Connect rollout plan. Line upgrades, Jubilee Line is being tested. Victoria Line first train, Subsurface first train due. But it's starting to get really busy. This is an exciting programme, one that is inspirational. And when I talk to kids especially, you see their eyes pop open when they hear about this stuff. It's fantastic stuff. I guess my challenge is this. We've had the time of the accountants. We've had the time of the lawyers who gave us the PPP. And that's all I'm going to say on the PPP. You've had the time of the planners, congestion charging. It's the time of the engineers. We have to deliver this. Look at the legacy we were left by the Brunels, by the pioneering signalling engineers, by the Becks of this world. That's the real challenge. Where are we getting the next Brunels from? And I seek through this type of talk to inspire people to become that, because London deserves it and desperately needs it. So on the final note, I think we're getting there. This came out of the Metro the other day, and it said for the visitors, remember the #1 tourist destination in the world, they thought we weren't doing too bad, so I reckon we're well on our way. Thank you for listening.